Because you and I, we can talk all we want, but we will never replace what nature is telling us directly.
Bomen stonden aan de wieg van de menselijke beschaving. Het menselijk DNA en dat van bomen zijn aan elkaar verwant. En ons leven is daardoor verbonden met deze oeroude levensvorm. We bezoeken de oeroude bossen van Noord-Amerika. Of wat er nog van over is. En gaan voor het te laat is te raden bij de bomen in het bos.
Well, believe it or not, this tree that I'm sitting next to right here is as informative as a bird song, letting me know what time of year it is, the sounds of the flow underneath it, the fact that if I mic'd this tree and tapped on another tree, I'd be able to hear it over here. It's a network here.
Gordon Hampton is akoestisch ecoloog en legt de geluiden van de natuurlijke wereld vast. Belangrijk in een tijd waarin het lawaai van menselijke activiteit dieper en dieper doordringt in onze bossen.
An acoustic ecologist understands that it's not the loud sounds that are important. That's common information. It's the faint sounds that has been pushing evolution. It was Emerson who said, listen to what the white pine saith. And then he stops. Because we cannot say what the white pine can say. And that's every reason to listen. Because you and I, we can talk all we want, but we will never replace what nature is telling us directly.
And what is that? What are they telling us directly?
You have to listen. You have to listen. I mean, are you asking for my white pine imitation? Okay. White pine needle is a longleaf needle growing in fascicles, 3 to 5. Little off key there. That's a pretty good imitation, I think.
Come on, go on. Go see your mama. She's over there. Over to your mama. Up there. Go. Go on. She's so upset. I don't want to upset her. Poor little baby. There isn't a day that goes by that I don't sit down by a tree or, walk through a forest or, and if I don't, then I feel funny. So I go find the trees and just be with them. I feel like the trees are like my comrades. What is it about trees that make us so alive? Why are they so integral to our lives and the health of our ecosystems and our planet? And so I was drawn to that.
Simard's levenswerk draait om de gedachte dat wij verre familie zijn van de bomen. En dat deze oerbossen ons daarom veel te leren hebben.
This is one of the oldest forests in the mainland area. It hasn't been burned for about 500 years. So these trees, these big ones that you're seeing, are about 500 years old. If you think back to when North America was settled by Europeans, that was well before that time when it was mostly settled. So these trees are way older than most of our ancestors. They're actually our ancestors. We think of our ancestors as like our grandparents and our great-grandparents, and then the lineage of how humans evolved from, hominids. But actually, our most ancient ancestors, the trees preceded us, and prior to them were, just the development of eukaryote cells and bacteria, the prokaryotic cells. So our lineage goes back to the first organisms on Earth, and that's a really humbling thing that actually, that the trees are much more ancient than we are. So when most of us walk through the forest, we're seeing, these huge trunks, we're seeing leaves. We think that these trees are individuals, like I'm an individual, that they actually, really don't interact much with each other. But researchers have been figuring out for decades that they interact in so many ways. And that's what I study, is the social life of trees. Yeah, right here. Those are mycorrhizas. And there's a big thick fungal strand there. That's what that is right there. Amazing. Here's a white one and a yellow one. When we start actually putting our DNA primers, if we collected this and took it back to the lab and we amplified the DNA and then sequenced it, we would find actually in this patch there's probably 100 species of fungi. So not just, you can't see it with your eyes, but we can see it with our DNA tools, which is really cool. So what's happened is that ever since plants evolved and came out of the ocean, they immediately started to partner with fungi. And the fungi do a lot of work for the trees, and the trees pay them with photosynthate, with carbon that they fix in their crowns, in their leaves. There's so many threads and so much shared fungal species between trees that they can actually link up. It's like a huge internet. And the forest is packed with these threads. There are miles and miles and miles of interconnecting highways that link this tree even with its neighbors. We're just starting to touch the surface of what's going on, but what we have figured out is that it's a way for trees to communicate with each other. They can warn each other when there's an insect, for example, or a disease in the area, and they can upregulate their defense chemistry in order to, prepare themselves for what's coming. We're starting to uncover the language of trees through these below-ground networks, and it is just as nuanced and complicated as our own languages. But I know the fundamental building blocks involve carbon and nitrogen, water, certain chemicals that are like our own neurotransmitters. So that Douglas fir has got a relationship with this hemlock. It has a relationship with, that Douglas fir that's even 50 meters away. And those relationships are really complex, just like our own. Right? We have friendships and we also have enemies. We have acquaintances, we also have relatives. We interact with our neighbors, but also like our doctors and bankers. We have complex societies, and so do they. They're just as complex. It's just that we never really, as people, look that hard or really seem to care that much, at least in our recent history, about these intricate, dynamic, special relationships between trees.
Als we samen zijn geëvalueerd op deze planeet, waar op de tijdlijn zou intelligentie dan zijn intrede gedaan hebben? Zijn wij misschien minder uniek dan wij denken?
Well, we think we're intelligent, right? The only species on Earth that's intelligent is the human species. Or maybe some animals, like orcas, are intelligent. But when we think of intelligence, we're always thinking of mammals or animals. But we evolved from these trees. We evolved from this forest. So what happened? You mean that it all stopped at some point? That evolution of what we call intelligence is not there? And I don't think so. So when I'm looking at the fungal network below ground, one of the things that we did is we mapped what this network looks like, and it comes down to, intelligence comes out of that map, right? It looks like a brain, and it's the fungi connected to each other, and through those fungi are transmitting chemicals that are the same as our own neurotransmitters. There's the basic chemicals are the same. So we've got the structure, we've got the chemistry. Okay, what's the third thing? Well, another thing that happens in our brains is we have these things called synapses. A synapse is where you have two neurons that grow together and you have a chemical that goes across that gap. That's a synapse. Okay, that's part of the brain structure. That's where the intelligence happens. That's where that new idea comes in that synapse. That's where the symphony orchestra plays its beautiful, songs. It's where our intelligence comes from. In a fungal network, there are synapses too, right? Where the fungus and the root come together in that symbiosis, that's a synapse, and there's chemicals that are crossing over it. Where a fungus and a fungus meet together and grow together, that's a synapse. And so now we've got 3 parts of what we think as the physical structure of intelligence. And so then I'm thinking, well, like we're so reductionist in our thinking, why wouldn't, we consider that to be the basis of intelligence? So what stops us from thinking they're intelligence? Well, it's our own hubris, right? That we think that we're the best and the greatest. And of course we are, but actually, when you start looking at nature and these patterns, these have evolved to be, they work and they repeat and they evolve. And so you see these structures that are the same as our own neural networks. You see them in the forest because they worked. And they persisted through millennia. So, yes, I think that the forest is an intelligent place.